looking at arithmetic sequences and series. A sequence is a list of numbers or terms or values that follow a certain pattern. There's lots of different patterns, there's lots of different types of sequences that you can make. Some that are really interesting, really have kind of a nice place in what we see in nature and kind of out in the world. We're going to look at two specific kinds in this course, the first being arithmetic sequences and series. So an arithmetic sequence has what we refer to as a common difference. We show this in an equation or formula when we're trying to generate a sequence by using the variable d. This common difference is a value that's going to be added or subtracted from each previous term to get us to the next term in the sequence. So a common difference can be a positive number, meaning that the numbers in the sequence are getting larger. It can be a negative number, meaning that the values in the sequence are getting smaller. So an example of an arithmetic series would be 2, 5, 8, 11, 14. We would find the common difference by subtracting terms. So one thing that we do have to be really careful with here is some notation. So notation tends to kind of throw students off a little bit when they first start studying sequences and series. So we use subscript notation. A lot of times you'll see the variable a used to represent a sequence. So a sub 1 means that I'm referring to the first term of the sequence of numbers. In example A, the first term is 2. Okay, a sub 2 would ask for the second term, which is 5. To find the common difference for an arithmetic series, I would take a sub 2 and subtract a sub 1. So I can actually take any two subsequent terms, like I could take a sub 4 and subtract a sub 3, because what I should see is that I'm always taking and adding 3 to get to the next number in the sequence. So the next number would be 17, so that would be the sixth term, a sub 6. The seventh term would be 20 if I kept adding 3. For B, the first term is negative 29, the second term is negative 28. So the pattern that we're following is that we are adding 8, so that's our common difference to get the next term. So negative 5 plus 8 would take us to 3, and then 3 plus 8 would be 11. When we get to C, 15, 12, 9, common difference is negative 3. So remember, we really think about a common difference being something that we're adding. So if I add a negative, that means that the values would be getting smaller. That's the same operation as subtraction. So the next two terms in that sequence would be a 6 and a 3. So again, the math component is not very tricky. It's really more about the notation and being very comfortable reading and understanding sequence notation. So there's two types of formulas that we look at and write. The first is called an explicit formula. The explicit formula allows us to find any term in the sequence without having to know the previous term. And so this is where some of that subscript notation comes into play. So to generate any value of an arithmetic sequence, any term, we use a sub n to represent the nth term. So it could be the 17th term, it could be the 6th term, it just depends on what they ask us to find. So the formula is always taking the first term, so a sub 1 plus n minus 1. So if they had asked us to find the 6th term, I would have plugged in the same n that for the nth term, so 6 minus 1, multiplied by the common difference. And so what we're showing is that we're just taking and we're repeating that addition, right? So that's why we take and use that multiplication there for the explicit formula. The other type of formula is called a recursive formula. We can write both types to generate a sequence. Now with a recursive formula, we have to know the previous term. So we would read this formula as a sub n is equal to a sub n minus 1. So what we're saying is 1 less than what I have right now. And sometimes I will kind of bring in that next now terminology, right? To find the next number in the sequence, I have to take what I have now and add the common difference. One thing you do have to know with recursive formula is what the first term is. Where are you starting? Because, again, the format of recursive formula just means I have to know the previous term. I have to know one term before to be able to find the next term. So we have to have some place to start. So let's look at some examples where we look at a sequence, then we write some rules for both of these. So example 1, for the following sequence, find the common difference. A sub 10, meaning the 10th term, the recursive rule, and an explicit rule for the nth term. And then they give us a sequence of -6, -2, 2, 6, and 10. So one thing to note is these, and the 3 dots at the end means that sequence is going on to infinity. It's never going to end. We can also have a finite sequence, so we talk more about finite sequences once we get into series and partial sums, which we'll study next week with sequences and series. So this just means that I would keep adding that common difference and going on forever and ever and ever versus a finite. They may only want 10 terms in the sequence for a finite sequence. So don't be thrown off by some of that different notation there. All right, so the first thing that we need to do is we need to find the common difference. And again, I can do that by taking any 2 terms and subtracting. So I can take 10 and 6 and find the difference between those and 4. And so I should also see that that's the number that I would add from -6 to get to -2. They want me to find a sub 10, but before I can find the 10th term, I really need to start by writing this explicit rule. So a sub n, again, I can find any term of that sequence without having to know any other information other than I do need to know the first term, so a sub 1 plus, and remember we said n minus 1 times the common difference. So we're just going to plug in what we need to know here. The 2 things we need to plug in are a sub 1 and the common difference. So a sub 1 is -6, plus n minus 1 times the common difference we found, which is 4. And you can leave that in that form. It's really easy to pull information. Like I can look at that right away and know that my first term was -6 and the common difference was 4. We can also simplify that algebraically. So you could go ahead and distribute the 4 and then combine like terms. And we would get 4n minus 10. Those 2 things should generate the same sequence of numbers. The difference is that the 10 is not my first term. So you do want to be a little careful with some of that notation. So typically I would leave it in this form, but just know that we could also write it in this like simplified form here. All right, so there's my explicit rule, because that means that if I wanted to know the 100th term, I would just plug in 100 for n and simplify it, and that would give me the 100th term. I can also convert from explicit to recursive. So for the recursive formula, we would say a sub n, so that's the next number in the sequence, means that I take a sub n minus 1, what I have now, and I'm going to add 4. I'm going to add the common difference to get the next term, and we started at -6. Okay? And so that would be how we would write a recursive formula. So if I wanted to find the 100th term using a recursive formula, I'd have to work my way up to the 99th term. So explicit goes much faster. Sometimes our brain just kind of sees that recursive formula a little bit first when we think about common difference. So to find the 10th term, I'm going to take the explicit term and I'm going to plug in place of n, because the n is representing the term that we are finding. So 10 minus 1 times 4. So -6 plus 9 times 4 is 36. 36 and -6 would be 30, and that would be the 10th term of that sequence. So again, the math is all stuff that you've seen and worked with before. They're very similar to linear functions. A lot of it is really just getting used to the notation. All right, example 2. They tell us that the second and fifth terms of the sequence are 3 and 24 respectively, just meaning that we're going to go in the same order that they give us the values. So a sub 5, the fifth term would be 24. They want us to write an explicit and recursive formula for the arithmetic sequence. So there's a couple different ways that we can think about this. So this would be your second term, third, fourth, fifth. And we know that we started here at 3 and we went to 24. And so we are adding the common difference 3 times. So what I kind of tend to think about is that I can use that explicit rule to kind of work backwards. So I know that I have the fifth term, and it is going to be equal to the second term plus 3 times the common difference. And then we just plug in and solve for what we need to know. So I can plug in those terms that they told us that we had, and then I need 3 times the common difference. Subtract 3, so that's 21. 3 times d, divide by 3, so my common difference is going to be 7, which means to go backwards to a sub 1, I would subtract 3, so that would, or it's not 3, sorry, 7, so that would take me to negative 4. And then we can even kind of test to see if that would work. So 3 plus 7 would be 10. 10 plus another 7 would be 17. And then 17 plus 7 is going to take me to 24. So we need to make sure that we do answer the question. So we did kind of some math there and thought through that process, but we need to write the formulas. So the explicit formula would be a sub n is equal to the first term we said was negative 4 plus n minus 1 times the common difference, which is d. So there's your explicit rule. I think I misspelled that. There we go. Just pretend that looks okay. And then we would also have our recursive rule, which says that I need to find the next term in the sequence by taking the previous term, a sub n minus 1. I'm going to add the common difference of 7. And we started with a first term of negative 4. And that would be my recursive rule for that sequence. So again, we had a lot of scratch work up there to get to those 2 final formulas down there at the bottom. There's some other language they could use. They could ask you for a closed rule, a closed formula, explicit formula. Any of those things just mean to write the formula in a way that you can find any term of the sequence. An arithmetic series means that we're taking and adding together the terms of the sequence. Okay. We can only find the summation of a finite arithmetic sequence. So again, we talked about this idea of finite meaning a certain number of terms. We can't find the sum of an infinite sequence because if the number is, the terms are gradually always either increasing, meaning I'm adding something to make them larger, or subtracting something to make them smaller. The sequence is going to diverge, just meaning it's never going to come to a concrete number, right? Infinity and negative infinity are infinitely large. We can't calculate what those values would be. Another way that they will ask you to calculate for a series is called a partial sum. And again, what we're thinking about is I'm just taking a piece or a part of that sequence and adding those numbers together to get the total value. The formula for an arithmetic sequence would be S sub n, meaning summation of n, certain number of terms, is equal to that number of terms. So if you were adding 10 terms together, n would be 10, divided by 2, and then it's multiplied by the first term added to the last term. Okay, so if you're adding to the 10th term, you would add the first term to the a sub 10, the last term, and then that gets multiplied by 5 because 10 divided by 2 is 5. So a couple of examples. Find the 20th partial sum of the sequence 15, 13, and 11. So we're going to have to do a little bit of work with this one. I'm going to put this other problem up on the screen and then we'll work through this. So the 20th partial sum means that I'm adding 20 terms together. So we can start by saying 20 over 2 times the first term is 15. Now what I don't know is I don't know the 20th term, but we can do some of that work from before to help us find the 20th term. So a sub 20 would be equal to the first term 15 plus n minus 1, so 20 minus 1 times the common difference, and in this sequence we are always decreasing by 2, so negative 2. So 15 plus 19 times negative 2 would be negative 38. Cheating and making sure I got it right in my head, but I was good. So negative 23. So add negative 23 as this last term. So 15 minus 23 is going to be negative 8. I'm just trying to figure out where I'm going to write this. We'll go up here. So we would say 20 divided by 2 is 10. That's negative 8. So negative 80 would be the 20th partial sum of the first. So if I added together the first 20 terms of that sequence, all of those numbers added together would be negative 80. Second example, determine the sum of the first 100 positive integers. So we're starting at 1 because, again, 0 is not integer. It's neither positive nor negative. Let's make sure we remember a little bit of our math knowledge here. So 100 integers, so 100 divided by 2. The first positive integer is 1. The last of the first 100 would be 100. So we would have 50 times 101. I do have to do that one on the calculator. I don't know that off the top of my head. 5,050, even though I've done this problem 100 times, it seems like. All right, so 5,050. So if I took and added 1 plus 2 plus 3 all the way up to 100, I would get 5,050. If you have questions about any of the notation or need help with any problems, make sure you send me a message, and I will get back to you as soon as I can.